All right, I think we are live. Good afternoon, good morning, everyone. My name is Alex Page, and I'm on the continuous testing side of solution engineering over at Broadcom. Um, Today, we're going to talk about our continuous testing platform, which we've codenamed Blaze CT. So just a brief bit on me. I come from a developer background originally, wrote software for a few large companies, was heavily involved in the test automation side of things, as well as CI/CD, and then just core Java development as well. So yeah, I am excited to talk about the ways that we've kind of expanded BlazeMeter, which you may have already heard of, um, into more of a continuous testing platform as opposed to where it started, which was more performance testing focused. So the main problem I have is keeping my deck up to date because we are investing so heavily in the expansion of this platform that it seems like every week there's a new capability or feature being added. So on that note, it will be tough to go into a lot of depth with what I plan to show you, but I hope to give you a wide breadth of kind of where we're going with making this truly a self-service, one-stop shop continuous testing platform. So let's begin. Move on to the next slide here. So just a couple intro slides. I think we're all very well aware of the problem or the challenge. And really, when we talk about the process of kind of testing and validating software, the goal and the whole reason why we're even hearing of things like Agile and moving towards that, and DevOps and shifting left, testing early, testing continuously, is because when we find bugs later, and worst case scenario in production, it's very impactful. It can cost a lot of money. We can lose customers. They're harder to fix later on in the cycles that we detect them. So if there's issues, and there's going to be issues and bugs in our software, we want to find out as early as possible, ideally in sprint. And that's hard to do because the activity of testing involves a lot of moving parts. But quality matters, and that's the first challenge. The next thing is performance. And so this is, more and more relevant as we, enter this and continue with this kind of on-demand, I want everything to work, immediate. I have no patience as a customer. If a site's taking 10 seconds to load, I'm out. I'm going to go look at an alternative. We have zero patience, so performance really matters. And this applies to customer-facing sites, but also internally for any internal applications or APIs that are supporting operations. We don't have the luxury of waiting around. Things need to just be performant. So performance matters. So we think about testing and what it's traditionally meant and what it entails. And, I work with a lot of companies. Most of them are moving towards an agile approach, but I still see a lot of kind of mini waterfall. We've gone through the safe training, but we still have a hardening sprint, which is where we do all of our testing. And so it's not really embracing Agile unless we embrace the continuous testing spirit of Agile, where I'm testing up front. So if testing is still a time-boxed event that happens kind of later on in any capacity, that's not continuous testing, and that's really not Agile. And that's not going to allow me to find all of my bugs and my issues up front. I'm going to find them later, and that's going to cost more time, more money. So instead of a time-boxed event where testing occurs, we want it to transform into a continuous testing process where it's happening all the time and really upfront. So we want our tests defined as soon as possible. So we need tooling to be able to create tests faster. We need to integrate it into our pipeline so that these tests are continually running. I check in new code, my regression tests automatically kick off, they're automated, and they run as part of my pipeline. And if there's an issue, I'll find out immediately, and then I'll know, oh, that code I just checked in introduced a bug. Not a month later when it's in production along with 100 other changes, and it's now much harder to find out what caused it. So the spirit of continuous testing is really the backbone as far as the guiding principle of how we designed Blaze CT, the platform. So really the challenge in achieving continuous testing, we feel strongly, is a lack of modern tooling. So what we've done is we've taken BlazeMeter, which is a SaaS-based application that facilitated performance testing, and we've expanded it to now allow you to generate and create and execute functional tests at an API level or a UI level. We continue investing in the performance testing side of it, and we've kind of started bridging the two tabs, if you will, so I can do things like run an end user experience monitoring performance test, where I have a load test occurring at the same time as a functional UI test, and so I can see when my system's under load, what is my front end user experiencing. So a lot of things like that, a lot of synergies between the capabilities. In addition to that, it's not just defining and running tests that we have to deal with as part of testing. There's all kinds of environmental dependencies. So maybe I'm testing my application, but it calls some third-party service, or it calls some other team's engine or API as part of its unit of work. And if that application isn't fully developed, they haven't incorporated the new changes, if it's down, if I have environment issues, that's going to affect my testing. I can't really run my tests because they'll fail due to this third-party service or external service being down. So we've given them the ability to quickly mock out those services and remove those dependencies. And then finally, we're embracing the idea of DevOps, where if you really are moving into that model, the agile teams should own quality from start to finish, from development through production. So we've added a capability to monitor your APIs and services in pre-prod and production environments continuously. So when things start to go wrong, we find out about it immediately, and we can take action. So again, this is an evolution of BlazeMeter, which is at its core a SaaS-based solution that has on-prem components available to facilitate execution of tests behind your firewall. But the main interface is blazemeter.com, which is a SaaS application. That's kind of where you'd go to generate all of these tests, run these tests, create your mock services. It's the one-stop portal that you'd use to interface for all this functionality. But everything that we do in the UI is accessible via API call. So I can incorporate executing tests, creating mock services as part of my CI/CD pipelines very easily because we make everything available via API. Another thing is that we embrace open source. So really, BlazeMeter started with being heavily built on JMeter. And since then, we've added support for the execution of tests in a variety of frameworks, including Selenium, Gatling, Cucumber. So we have kind of an encapsulation engine called Taurus, which is an open source project we put out and really is the engine behind BlazeMeter. And that encapsulation engine lets you run tests, and I think it's up to about 20 different frameworks. So we don't try to fight open source, we try to embrace it. So quite the contrary. So yeah, I mentioned the fact that this is a SaaS-based application, so you're not dealing with upgrades and all the kind of logistics and infrastructure with that. So when we release new features, and we are releasing every 2 weeks to production, if those are SaaS-based changes, then you'll just automatically be able to take advantage of those the next time you log in. We do have the on-prem component because many of our customers need to execute the tests from behind their firewall, and we make that as easy as possible with a series of Docker containers that you kind of spin up the orchestration container once, and then it runs itself from there behind your firewall, and that's where the test will execute from. But as far as the maintenance, it's really as low touch as possible. Again, SaaS first is kind of our approach there. Okay, so moving on, getting into some of the core use cases. So this is one of those slides I probably need to update because there's been definitely some enhancements that would expand on this list, but I would say 4 core use cases would be scriptless test automation. So I mentioned we are compatible with a lot of different frameworks out there. So if you've already got Selenium tests that you are happy with, that you want to continue running, we will let you run those on the platform, and you can take advantage of the unified reporting. But if you don't want to deal with writing test automation, we provide several ways for you to automate tests in kind of codeless and scriptless avenues, from our recorder to a scriptless UI test definition editor. So doing a few things with the codeless side of it. I mentioned end user experience monitoring, and so that would be when you want to run a load test against your backend system at the same time as a front end test, so that you can see in the same report, okay, when I put my system under load, this is what the user on the front end is actually experiencing. So again, kind of merging functional with performance would be one additional use case. A lot of customers are excited about that. We talked about using mock services to eliminate environment dependencies, and I'll show that in a little more detail in the demo. And then finally, the 360-degree API functional testing and monitoring would be the what was formerly known as run scope, which we've built into the platform to facilitate the continuously running functional API tests against APIs that can assert on performance and actual response payload content, to ensure that our APIs are not only up, but that they're performant and that they're functionally correct. And when they're not, we get alerted immediately, and we can connect that to downstream workflow engines to even automate the remediation action taken. Okay, so I will go through these next slides pretty quick because I'm going to demo to all of them, and we kind of covered them in that first intro slide. But one thing that we offer is the BlazeMeter Chrome extension, which is a recorder. And this will let you record a front-end test, and it's going to capture all the front-end actions you did as Selenium, let you export that into the platform as a functional test, but it will also capture the back-end calls that the browser was making during that front-end test, and we can turn that into a performance test. We can also turn it into a combined end user experience monitoring test right from the recorder. Another thing that we have recently put out as general availability would be the quote scriptless functional UI test editor, which lets me create a front-end test without having to write any code. And I'll show that briefly as well in the demo. Again, the same web scale performance testing, load testing that you know and love with BlazeMeter still exists today, and we are continuing to invest in that and the rich reporting that you get out of running performance tests, JMeter based or otherwise, on the platform. And then finally, or not finally, but next we have end user experience monitoring, which again I spoke to and will demo to. This again is the load test at the same time as the functional test. The key here is that I've overlaid both metrics on the same report, so I can see based on load what impacts are there to the front-end user, to my customer, again in the same report. Okay, so now moving on to mock services. So this really, if you're familiar with CA tooling, there's a product called Service Virtualization, formerly known as Lisa, where I can virtualize anything under the sun from mainframe to JMS, messaging queues, and HTTP services. Anything out there we can virtualize. Mock services is kind of the simplified interface to let you mock out HTTP-based services, so REST and SOAP APIs, directly on blazemeter.com. So you can import a Swagger or a WSDL definition to build out these mock services very quickly, and then control them, start, stop them, and associate them to the tests that depend on them being up directly in the platform. So again, not needing any kind of on-prem tooling to get that going. It's just a part of BlazeMeter now. Okay, and then finally the API monitoring component, which again formerly known as run scope, is now represented as the API monitoring tab here. And this is again to continuously test and really monitor the APIs and services we have in pre-prod and production. Okay, sure, a lot of people have questions. I went through a lot there. So if you have any, just throw them in the chat and I will continue on to the demo. So let me share my screen. Okay, I think you should see the screen now. Okay, so blazemeter.com, here I am. I have my dashboard up in front of me showing me the recent functional tests that I have executed and edited. And that's because I'm in the functional tab here. So whereas BlazeMeter .com before was just really performance testing. We now have separated out new capabilities in these high-level tabs up here. And so we're going to start with functional testing because I'm going to kind of simulate a true DevOps Agile team, someone on that team who's responsible for validating software start to finish, what a day in that life might look like using our platform. So let's say I have a web application, and it's going to be called Digital Bank, and I'm responsible for validating a new feature that we've added to this Digital Bank application. So I'm just going to kind of manually run through a test here. So I'll log in, and the feature that we've added is a Visa Direct Transfer. It's, I guess, like bill pay. So we've added this feature where you can now select an account that you want to transfer money from, one of your bank accounts, and then the transfer amount, and it will send it directly to Visa in, again, like a bill pay kind of mechanism. And so then when that request is made from my application, obviously I'll get a response, and that will indicate if it was successful or not. But the actual API that this web UI is going to send that request to is not owned by my team. Maybe it's Visa's actual API, or maybe it's some internal Teams engine that's handling that API, and then they call Visa. Doesn't matter. The point is that I'm responsible for developing this web app, but not this service that my web app needs to call. So I've done my UI changes to display and render to the user the kind of success message when that's returned from this call, but I'm not in control of that service actually being up. So if I went to go and try and test this, too bad, the service is down. So I'm kind of stuck here. I can't really validate whether or not my UI changes are going to properly render the successful response because I'm not getting a successful response. That service is down. So already I'm kind of stuck. And I can tell you from personal experience, this is usually when I'd go off and code out some Java application as like a stub, which turns into the if-else logic nightmare. It's not the way to go. There's a better way. So what can BlazeMeter offer me at this point? Well, if I hop over to the Mock Services tab, here I can see a very simple interface that's displaying all the mock services that I've already created and allows me to create new ones very quickly. And really all a mock services, it's an endpoint that is running and that can be called, and it will take in any incoming requests and then evaluate them against the transactions in that mock service that I've defined. And a transaction is going to have matching logic. So it'll say, look for this value on this field of any incoming request. And if you match on it, then return this response. So it's really that simple. A mock service is an endpoint, and it holds transactions which define the matching logic of incoming requests as well as what to return when you match. So I talk about these transactions, and there's a lot of ways to generate them and create them, including importing a WSDL or a Swagger spec to automatically generate these transactions. But I can also create them manually by hand if I want to. And so here I've got a few transactions already in that mock service, and this is for that Visa API that we're now kind of stuck on. So this transaction is going to match on the, say, amount field, matching the regex right here. So really any number, any numeric number is what I'm matching on. And then, well, what am I going to respond? Well, here's where I'd simply put the valid payload that I expect on the response. And so this is what my UI is expecting to be able to parse through and then display relevant details to the user. So just to prove to you guys I'm not doing any demo magic, let's say hello Star East, or sorry, Star West. Okay, so I've made that change to the response that I'm going to return on this transaction. I'll go ahead and save that. And then I'll pop back over to my mock services view here and simply update the mock service because I changed the transaction. It's going to hot swap that in place very quickly. And now my mock service is up and running. So the next thing to do is just point my web application to that mock service. And I've already done that with another instance of Digital Bank here, which is at a different IP address. So this instance is pointing to that mock service that we just edited. And so now when I log in and I go to Visa Direct Transfer and I choose an account and say an amount, now it's going to hit my mock service, which is returning the valid response payload. And I can now see that my UI changes are working properly and I'm displaying what I need to the user. So I'm no longer stuck. And here we can see the hello StarWest that I added in that response. So I can actually see that this is hitting the mock service and I'm no longer stuck. Okay, great. So we've eliminated the dependency that I have in this specific use case. So now I'm ready to start automating some tests. Let's automate that test that we kind of just ran manually. So I'll back up to the front of the web app, the login page, and I'll go ahead and use that BlazeMeter recorder. That again is just a Chrome extension. And so when I turn this thing on, I can give the test a name and simply start recording. And now one thing that you'll notice is that there's a UI and JMX section here. And so these are going to uptick based on if I'm doing any front-end actions, it will uptick the UI part that's being recorded. And then any back-end calls being made will be upticking the JMX side. So I can kind of organize my recording by renaming these section labels. So I'll maybe say login is the first thing that I'll do. And I just simply start performing actions. And you can see it's upticking here. And it's capturing everything I'm doing and the backend calls being made. So there was a post request from hitting that submit button, and that was captured here. So maybe the next thing would be navigate to transfer as far as my next section of this recording, and then I'll just continue doing actions on this UI. So I'll hit Visa Direct Transfer, and then maybe I want to say enter transfer details. Next section, I'll add that step, and now I'm going to select from that drop down, maybe choose 10 here. Okay, and then I'll hit submit. So we just recorded a backend call there. And then the last section, I might say validate successful transfer. One thing our recorder lets you do is actually add assertions while recording. So I might want to assert that I see this text here. And so I can highlight it and right click, and I can add an assert text. And so I just upticked from 1 to 2 here. That assertion was added to my recording. So then maybe I'll finish the test by just going home or something like that. And let's say I'm done. So I stop the recording, and now I have a bunch of options. I can play that back immediately just to see it running locally if I want, but I know I'm happy with it, so maybe I'll import it into BlazeMeter as a functional test. Maybe I'll start with importing it as a GUI functional test. So I'll just choose that from the dropdown, and it's going to automatically create that test in BlazeMeter as a scriptless UI test. Now it's stored the Selenium code that was recorded behind the scenes as well, but it's going to by default display this test to me in a codeless representation. So in this interface, I can add steps to this test. I can move things around. I can change the data. All of these steps are editable. There's a lot I can do here. I could talk about this scriptless interface for an hour. We've got a centralized object repo to store all of your objects and elements. I can use reusable keywords that are sequences of steps that are common across tests. I can do all kinds of things with test data, generating synthetic data, or pulling data from the back end to populate my tests. I can iterate through 100 rows of a CSV file, populating different fields that I'm entering as part of my test as well. So much I can do, and we have so little time, so I can't really show much of it. But this is a very rich interface that we've invested in pretty heavily, and we see a lot of industry, a lot of large companies moving towards kind of codeless test definition interfaces to let more people build tests that perhaps don't have automation scripting skills. So here's that scriptless test that we recorded, and it's pretty easy for me to make changes and edits to it. Let's say I'm happy with that, and I will move down to the bottom of the test here where I can say where I want this functional test to run. So I could choose any on-prem location I have set up, which are listed under private locations, or any of our cloud engines. I'll choose cloud engines for now. And then under the browser selection, I can add any browser version combo that I want. So we currently support Chrome and Firefox, but we're expanding to IE and Edge very shortly. So maybe I'll choose Firefox 76, and then maybe 2 versions of Chrome, let's say 81 and maybe 80. So 3 different browser version pairs that I've selected here. When I run this test, it's going to run it in each of those browser versions that I've selected and kind of aggregate it all up into one report. So I could run this test and it will kick it off and then shortly after display me a report. I've already executed this test and we are definitely running out of time, faster than I anticipated. So I'll switch to the already finished version of the test. Doesn't take long though, 38 seconds for a 3 browser test, not bad. And I can drill down into any of these different browser sessions to see what happens. So we'll take a peek at Chrome. I can see my sections split out here based on, again, how I recorded it originally and how it was defined in the scriptless test. And I can expand any of them and click on any step I want. It's going to fast forward to that part in the video. I can play through the entire video, see exactly what happened. I have all kinds of logs that were captured, a waterfall report of the front-end network metrics, and really all the information I would need about this test automatically stored. And then if I want to take a look at the Firefox session, I can just pop back up to the summary and then drill into the Firefox session, and I can see indeed the signature Firefox browser. This is the Firefox version of that test, and everything looks good. If anything failed, I would see that clearly here, but this test was successful, so it's all green and passing. So that's one entry point to functional UI testing. Don't have enough time to go into any of the others, but there are plenty. I think that's the newest and one I'm the most excited about, so was glad I got to show that to you today. But now let's shift gears. So I want to also run a performance test, because if we're truly embracing shift left, I don't wait till right before production to run all my performance testing. I should be doing isolated and component-based performance tests in sprint. If I've introduced a change that degrades the performance of my application, that's going to be way easier to detect if I'm running performance tests right after I make the change versus right before production when there's 100, 200 other changes that are also in that build. Okay, how can BlazeMeter help me with that? Well, I can start again with that recorder. And so this still has in memory that recording that we went through together. And from here, I can go ahead and directly import this, the backend calls that this captured as a performance test. I can also, by the way, download any of these test assets that the recorder is giving me locally if I wanted to make any changes to them. So when I download the JMeter file that this recorder generated, which again was all the backend requests that my browser made, I can open it up in JMeter, which is the open source tool of choice for performance testers, I'd say pretty unanimously, and I can make any edits I want in JMeter. And a lot of our customers are using JMeter to author their performance tests, but this recorder built this entire test for me. So I'm hitting the ground running, and I might make some edits here, maybe not. I might be happy with this as it is, but I have the full power of JMeter at my fingertips, which again is backed by the very large open source community that's been active for years now. So I can use JMeter as my IDE for performance tests and grab that asset, that JMeter file that the recorder generated for me as a very good starting point. So maybe I make some changes here, and then when I'm done, I can just upload that JMeter file as a performance test. In this case, I'm not actually going to make any changes to it, so I'll just upload it directly from the recorder by hitting the performance option here. And so this will create a performance test with, again, that JMeter file that we just looked at. And so once it's sent it up to the platform, it'll automatically open a new tab and actually start the test. And so I'm going to take a look at this test configuration, and I can see it's grabbed that JMeter file that the recorder generated. And now I can start kind of toggling up my load configuration and set a few things in this performance test. So maybe I'll add in that Selenium YAML that we just downloaded because I want to do the end user experience monitoring along with this load test. So anyway, with the load configuration, I can kind of toggle this up as I see fit, and I can add in maybe some ramp up steps to kind of control how the load will be scaled up throughout the test. I can add any location that I want as far as where the load's coming from, and this can again be in any private location behind your firewall or any of our cloud engines across the world, and I can distribute the traffic however I need to. Another thing is this load test is dependent on that mock service that we created. And so because that mock service was created on BlazeMeter and we know about it, I can say, hey, this test depends on that mock service. And so now this test is becoming more self-defining. It describes what it needs. And if this mock service was down, when I try to run this test, it will bring it up for me. So it's kind of the beginnings of how we're making tests truly self-defining, and they describe the services they need, and very shortly they'll be able to describe the data that they need in a dynamic fashion that's resolved at runtime. So this is how I kind of link it to that mock service. A few different options here. I won't get into all of them. One thing I will turn on, though, is end user experience monitoring. And so here I'm just choosing that front-end Selenium test that, again, we recorded to run at the same time as this load test, so I get these end user experience data points in my resulting report. I can also tie in this load test with APM. So AppDynamics, Dynatrace, our APM solution. And so once I do that, I'll get the load test metrics as far as request response times that I automatically get with BlazeMeter. I have end user experience monitoring enabled, so I'll get the front end, front end test data points as far as what the user is experiencing on the front end. And now that I've integrated APM, I'll actually get detailed metrics as to function level and query level performance internal to my application and the server that it's sitting on during this load test. So really all of the data you'd ever care about, all correlated in the same report. So I can then go ahead and run this test, and I'll just skip to a already executed version of that because that would take 20 minutes to run. And here I get the performance test report that if you've used BlazeMeter before, this should be familiar. And so I have kind of this high-level view of the things that I probably care about, but the ability to drill down into the timeline report. And so I'll do that now. And so in this timeline report, I can now overlay the end user experience data points. So that functional test that was running, I can see the individual data points for each section of that front end test. And so I can see here that my load was constant, but halfway through the test, my response time definitely worsened, but I can see that from a front-end user experience perspective, they were dramatically impacted. So for this particular step, the front-end user is sitting for about 10 seconds. That's probably not good. Because I've integrated APM in this test, now I can actually overlay any of those APM data points. So I could say, hey, how was the CPU utilization during this test? Okay, that doesn't look related. I can peek at any of the actual database queries that my application internally was making, see if any of those were the culprit, maybe a slow database. So really all the information I would ever want to not just identify that there's a performance issue, but get to the causes and conditions very quickly. And then one last thing with the end user experience side, I forgot to go into, for any of these data points, I can actually drill into them, get a full screenshot view of what the user was looking at during that, that functional test, and a waterfall report that gives me metrics as to the browser, the client side, what was perhaps the culprit of an issue. So this post request that the browser was making seems to be the issue, and that is to this particular endpoint. So again, just bringing together all the information I'd ever need and care about so that I can quickly determine what were the causes of what I'm looking at. Okay, so the last thing I want to go through would be the API monitoring side of it. So we've created our functional tests, we've removed our dependencies by creating a mock service, we've created performance tests, and we're executing those all up front through our CI/CD pipelines. We move along in the dev cycle when we're releasing to production. And, when I was a developer, I had a pager, literally a pager, and at 2 in the morning, it would beep, and I'd have to get up and deal with it, log on, scrape the log, see what's happening, scale up instances of the application to meet increased loads. So I had to deal with production issues as a developer. And so a lot of, that's the direction that we see things going. It's really embracing the DevOps model of quality ownership from start to finish by the Agile teams. And that's what this really is for, API monitoring. So you think about APM, App Dynamics, our APM tool, Dynatrace. These are excellent tools and very important, and almost every customer I deal with has one of them. But that's kind of a passive approach. Again, it's important to have that, but those tools will let us know when existing traffic, customer traffic, is starting to be impacted. So a database goes down and my customers are starting to face an issue when they're trying to access this page that relies on this database being up. Then I'll get alerted about it. But what about a more proactive approach? What about if I had API tests that were continuously running in my pre-prod and production environments? And then when things go down, I'm immediately notified, hopefully before my customers are impacted. And that's what this capability is going to let us do. So I simply define my API tests in a Postman-like interface. And if I look at one of these tests here, I can see this interface to create them. Very simple, very mature interface. I actually love this side of the platform. It's one of my favorite parts. I think it was really well done. I just simply define my API calls. So here's the request. It's a post request to this endpoint. Here's my query parameters. I could supply the request body. I can define assertions. I expect this to be to return a stat code 200, and I expect the response time less than 500 milliseconds. I can extract data from the response. So I'm going to extract the auth token from this response, and then I'll use that in a subsequent call here. In the authorization header, I'll use that extracted auth token because these are now authenticated calls. Really, any use case you could think of from an API testing perspective is covered here. And so I can use this interface to build out my tests very quickly, run them immediately. These also can run on-prem, of course, and then popping back to that dashboard view, get a very quick look at, okay, is everything up? I can connect this to downstream workflow engines. There's a bunch of services we allow you to connect this with, so that, say, if an API call is taking too long or the response isn't functionally correct, I can create an event in Splunk, send a message in Slack. Quite a few integration options here that you can connect those monitors up to. And then the last thing I'd say on it is that a lot of the time, developers, and I was a heavy user of Postman and SOAP UI, will already have those API calls in some form, and I want to make use of those. And this tool lets you do that very easily. So I can import a Postman collection, or I can import a SOAP UI test collection. So I can import tests that I already have very quickly. And we've got a few minutes. We'll do that right now. I'm going to open up Postman, where, say, I've already got some API calls for that digital bank application. I'll simply export this collection out of Postman and to my downloads folder. Sure, I'll replace it. And then if I pop back over to API monitoring here, I'll choose Postman, choose the file, select that Postman collection, and import the requests. And boom, I have a API monitor created with all 4 requests. It's properly parsed everything out, and including the variables that I had defined in my Postman tests. And now I have those tests available that I can set on a schedule. Say I want this to run every minute, and connect that to my my workflow engines, Slack or whatever. And now this is going to automatically run. I can have it run in multiple environments. And now I'll be proactively notified when things go down, when my endpoints are not functionally correct or non-performant. I'll be proactively notified. So we've got about 6 minutes left. I know that was quite a bit, drinking from the fire hose, and I didn't actually even get to half of what I'd like to show, but we just don't have enough time. I do want to allow some time for questions if we have any, and of course happy to facilitate any follow-ups to dive deeper on any of this. But I would say, just head over to blazemeter.com and you can open a free account and start testing out really all of what I showed today. We have great documentation at guide.blazemeter.com. There's Blazemeter University, which offers educational training content for all of this stuff, and even test automation best practices, So check out BlazeMeter University, and yeah, get your hands on the tool, start using it for yourself. Okay, let's switch over to any Q&A that we had. All right, so I see one here. Can you use the mock service to validate the API request from your app? In other words, pass or fail whether your app is sending the appropriate API request for each scenario. So that's a good question. So really the mock service should mimic the working application, right? So when it gets a request, what is the correct response that it should send back? That's kind of one use case. But another use case of mock services, which you've kind of brought up here in this question, which is excellent, is testing out the kind of negative conditions. So what happens if the service that I'm dependent on returns me a 500 or a 401 or some error response? I want to see how my application responds to that. Is my application resilient to its dependencies going down? Because that's going to happen in production. And so I can make my mock services, I can build them up with transactions that aren't just happy path, but I could say, okay, when you get this specific amount, say, so if the amount is set to 15 on that call, just an arbitrary kind of matching selection here, I want you to return a 500 error and error system failure in the payload. And so now I can have one of my tests that's going to send in 15, and I'll know that I expect to get this kind of 500 error response from my mock service, and I can see if my application handles that gracefully, and it should. So it's kind of like the testing done on building an airplane, if you will. It's through the wind tunnel. They don't build the whole airplane and then test it. They test the individual parts. So they test the wings, they test the engine, each engine specifically. So you'd want to make sure that you really are testing all the different scenarios that can happen, including system outages and negative scenarios. Your applications really should be resilient to those things happening, because they're going to happen. And so because I'm in full control of what this mock service returns, I have the ability to very easily do that. A lot of the things out there that do mocking, like Mockito, and others, there's plenty of open source tools. Some are starting to do it, but I've seen a lack of being able to facilitate that kind of negative testing. I want it to return a 500 in this case, so I can see what my application does. And it's really easy with mock services, obviously, to do that. Okay, next question. By continually running API tests, is there a concern of impacting the customer's usage of our servers, of our services? That's a great question. So if you noticed, the frequency that I can run these, I lost my tabs here. The frequency that I run these API monitors, the most frequent it can be is once per minute. So I don't think that for any kind of production application should be able to, that shouldn't impact it really much at all. One request per minute. So we're not load testing with API monitoring. You don't never want to load test applications in production. I see it all the time. It's bad practice. This is just sending a single request, in this case once every minute or once every 5 minutes, whatever makes sense given the situation. But that that single test, even as frequent as 1 minute, should not impact your application. If so, then we've got problems. But so no, this is really just a monitor. It's very low impact. It's just an API call. But I can assert on all kinds of things, from the response time to the actual content of the payload. So I can see, okay, if this is just one request, but there's 10,000 others and the application's chugging, it's going very slow, then I'll see that, and maybe my response time assertion would fail in this monitor test. So no, these aren't going to impact your applications in production in any kind of significant way. Yeah, that would not be a good thing. One thing though that we do see a lot of customers doing is they'll set up kind of test accounts or test entities in their production application that these monitors can hit. Because say if I had a digital banking application, I if I'm going to hit this API, I need to actually authenticate as a user. So they'll have some like kind of mock test users in production to kind of just streamline the logistics of doing this kind of thing. But there's a lot of different methods to kind of get around that problem that we're happy to help with as far as guidance. But that was a good question. Okay, we're at the top of the hour. So if there's any other questions, we can follow up on those. I hope this was helpful, and I hope you kind of see where we're going with this platform. But I want to thank everyone for their time today, and have a great week. All right, take care.